Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7. It says the graph of f of x is equal to x plus 4, x minus 6 is drawn below. The parabola cuts the x-axis at B and D and the y-axis at G. C is the turning point of F. Line AE has an angle of inclination of theta and cuts the x-axis and y-axis at A and E respectively. T is a point on F between B and G. So whatever that they mentioned on the statement, we can clearly see here on the diagram. Right. Then 7.1 says write down the coordinates of B and D. So if they say write down, that means it's something that you can visibly see from either your drawing your diagram or from just reading the statement here. So given our equation here, f of x is equal to x plus 4, x minus 6, we can see that that equation there is in the root form. Right, so if it's given in root form, that means we can find our x-intercept by just simply equating that to 0. So now we have for 7.1, that's x plus 4, and then x minus 6. If we equate this to 0, then we have our x-coordinates as x is equal to negative 4, and then also x is equals to 6. Now looking at B, we can see that it is in the negative x-axis, so it corresponds to that negative 4 is to 0, and then D is in the positive x-axis, so it corresponds to the 6 is to 0. And that's how you write down the coordinates of B and D. Now 7.2, it's saying calculate the coordinates of C. So as we can all see here, excuse the pun, we can all see that our C here is the turning point of the parabola graph. And then we know that the turning point, the x-coordinate of the turning point is known as the axis of symmetry. Then we can either calculate it using the formula x is equals to negative b over 2a, or we can simply just use the fact that the axis of symmetry is just the midpoint of the x-intercept. So we have negative 4 here, and then we have positive 6 here. To calculate this x-coordinate here, we can just simply take the negative 4 and then add it to the 6, then divide by 2. And then therefore we find the midpoint of the x-intercept, which correspond to the x-coordinate of the turning point. Right. So if we do the method there, this will end up giving us negative 4 plus 6. That's 2 divided by 2 is 1. Right. So now that we have our x-coordinate there as 1, then we can just do this, take that x-coordinate and then substitute into the original equation, x plus 4 and then x minus 6. So what we're going to do is that we're going to substitute 1 into x. So that's 1 plus 4. And then 1 minus 6, right? So when you punch this into your calculator, it gives you negative 25. So that means our coordinates for C will be 1 is to negative 25. So these are the coordinates for C, our turning point, right? Then 7.3 says write down the range of f. Note with the range of f, the range of a parabola, if we have a concave up graph like this, the range of the parabola is always starting from the y-coordinate of the turning point all the way to positive infinity. So every time you are dealing with the range of a concave up graph, just know that it is always y greater or equal to the y-coordinate of the turning point. But if you have a concave down graph like this, then obviously your maximum value there becomes the turning point. So this should be y less than or equal to the y-coordinate of the turning point. So this is simply meaning that if you have a concave up graph like this, the graph starts from the y-coordinate of the turning point all the way to positive infinity. But with this one, it starts from negative infinity all the way up to the maximum height, which is your y coordinate of the turning point, right? So that means to indicate the range, I will say this is y. Since I have concave up graph, this is y greater or equal to negative 25. Now, others might prefer the notation y is an element of negative 25 included all the way to positive infinite. So these are two ways in which you can represent the same answer there. So you can write your range like this, or you can write it in this form. So it's just a matter of notation, your choice. Then 7.4, let's proceed. Let's proceed to 7.4. It says, given that theta is 14.04 degrees and the tangent to f at t is perpendicular to AE. So they're saying we have a tangent at t which is perpendicular to AE. So if we can just try to draw the tangent there. So it must pass through t, touching the curve at only one point. So, but then now they're saying that that tangent there is perpendicular to AE. So at this point, we have our 90 degree there, right? So might not look perfect, but then, yeah, just to get the idea. Then 7.4.1 says, calculate the gradient of AE correct to 2 decimal places. We are given theta here. So that means in order to calculate our gradient, we have to use tan theta. So we have to use this equation here that goes tan theta is equals to the gradient. So we'll say it's equals to the gradient of AE, since that's the one we are calculating. Then our theta there is 14.04 degrees, which will be equivalent to our gradient of AE. Then when we punch that into our calculator, we find that our gradient for AE is 0.25, which can be written in fraction form as 1/4. Right. So that's 0.25 or 1/4. Then 7.4.2 says, calculate the coordinate of t. Right. So we can see that t here is just passing through the point t. The tangent is just passing through the point t. And then we don't know the x coordinate of t. We don't know the y coordinate of t. Now, how are we going to do this? We are given one piece of information. T is perpendicular to AE. So we know that the gradient, we know this about perpendicular lines. So this is what we know about perpendicular lines. If lines are perpendicular, for example, the gradient of AE now multiplied by the gradient of the tangent should give us -1. So we know that if lines are perpendicular, the product of their gradient will always be -1. So by product, I mean when you multiply the gradient, they should produce -1. But we already calculated the gradient of AE. So we can use that to find the gradient of the tangent. So let's say gradient of AE multiplied by the gradient of tangent is equals to -1. This is 1/4 multiplied by the gradient of tan, so -1. This point we should multiply it by 4 both sides so that we get rid of this 1/4 here. Then that's a gradient of tangent will now give us -4, right? But then now we only have the gradient. And then if we wanted to find the equation of the tangent, it wouldn't be possible because that tangent is only passing through t and then it's not intersecting with any other visible point. So now this is the part where we get to use the gradient equation, right? The gradient formula equation of the derivative, right? So this is where now we get to derive. So how do we find the gradient formula or the gradient equation? We want to go to the original equation. That's x plus 4, x minus 6. So note the conditions where we get to apply this. We cannot find the equation of the gradient, right? So no matter what we do, we cannot find that equation. So now we're only left with the chance of finding the gradient equation. So this will give us x squared multiplied by -6, that's -6x. This multiplied by that, that's positive 4x. And 4 multiplied by -6, that's -24. So this is x squared, and then a negative 2x, and then minus 24. Right. So at this point, let's derive. To find our derivative equation or our gradient equation, that's a 2x minus 2. Right. So the rules of derivation there. Then what is it that we should do right now, since we have found that? Since we said that that is the gradient equation, that means the gradient equation will be equals to the gradient. So f prime x is equal to the gradient of the tangent. Right. We are saying that at that particular point, the gradient of the curve is equal to the gradient of the straight line, which happens to be the tangent. So at that particular point, at that point of contact, the gradient of the two graphs are equal. The gradient of the curve at that particular point is equal to the gradient of the tangent, the whole tangent. Then, okay, so this is 2x minus 2 is equals to the gradient of the tangent, which is negative 4. Then that's 2x. If we transpose the negative 2 over to this side, it's going to give us negative 2, because negative 4 plus positive 2, that's negative 2. Then if we divide by 2 both sides, then our x value is negative 1. But remember, we are looking for the coordinate of t, not only the x coordinate. So now we have to take this x coordinate, and then where do we substitute it? Not into the gradient formula, but then we substitute it back into the original equation, because note, this is the point of contact. So that line, that point T exists both in the tangent and then in the curve. So we do not have the equation of the tangent, remember? So that means we can only find the y coordinate by substituting back into the equation of the curve. So at this point, let's substitute back into that equation. So allow me to write it here. So to substitute back there, we're going to say f when our x is negative 1, then this is going to be negative 1 plus 4, and then negative 1 minus 6. Then you punch all this into your calculator, you get a negative 21. So that means your coordinates for t are now negative 1 is to negative 21. So that point that you see there is negative 1 is to negative 21. And that's how you calculate the coordinates of t. Right. So all that for 5 marks. Worth it. Okay, then let's proceed to 7.5. So 7.5 says a straight line G parallel to AE cuts F at K, negative 3 is to negative 9, and R, then calculate the x coordinate of R. Now we can see that the points that are mentioned here, K and R, they are nowhere to be seen here in this graph. So that means we are the ones that should be able to kind of estimate where the points are, right? So they do that. So if you were to check there, you were to check your diagram there, you would see that there is no K, there is no R. But then they're telling you that that line G is parallel to AE. So you should be able to be in a position to kind of estimate where it is. So now we're just going to draw a line that will be that will be parallel to AE. So this is our AE. If we are to produce a line that is parallel, then the line would look somehow like this. So remember, it's not a matter of being precise, it's just a matter of trying to kind of make it sense, and then so that we can solve something that we see. So K here, we can see that the x coordinate is negative and the y coordinate is negative. We only have that in the third quadrant. Where we find our x coordinates and y coordinates both being negative is only on the third quadrant. So we can say our K value is somewhere there. That means R would have to be somewhere here. Because remember, they're saying that that straight line will intersect the graph at 2 points, at K and R. The only way it can intersect the graph at 2 points is if it goes like that, similar to the way AE is doing here. So it's intersecting at this point and also intersecting at that point, right? So these two lines here are parallel. What do we know about parallel lines? What do we know about parallel lines? What we know about parallel lines is that they share the same gradient. The gradients are equal. So if we have AE being parallel to KR, then what this means is that the gradient of AE will be equal to the gradient of KR, right? So we did calculate the gradient of AE. Remember, we found that it was 1/4. So that means, in other words, also the gradient of KR is equals to 1/4. Now that we've found the value of KR is 1/4, and then we have the coordinates here, -3 is to -9 at K, then we can find the equation of the straight line KR. We have the coordinates, right? So this is y minus y1 is equals to mx minus x1. Now the coordinates, let's use these coordinates. This is y, negative and negative, that's +9. And then our gradient is 1/4. X, the negative here, the minus and the negative, that's going to be +3. Then now let's just do the math. This multiplied by that, this multiplied by this, 3/4. And then -9 if we transpose the 9 over here. So this is 1/4x minus 33/4, right? So now we have the equation of line KR, right? We have the equation of line KR. But then what can we do to find the coordinates of R? Note that R here is a point of intersection, the same as K. Those are point of intersection with the curve, the graph of F. So how do we find the point of intersection? We already know to find the point of intersection, you just simply need to equate the equations of the two graphs. So that means right now we can take the equation of G. So remember they said that is line G. So this is line G. So we can say f of x is equals to g of x because we are looking for the point of intersection. What is the f of x? We did calculate this one. We did write the equation for this one in standard form. So that's x squared minus 2x minus 24 is equals to 1/4x minus 33/4. Now at this point, we can see that what we can do to calculate here is just simply multiply both sides by 4, right? So we don't want to work with the fraction here. We don't want to work with a fraction. So this is 4x squared minus 8x minus 90. So 24 times 4, is it 96? Yes, minus 96. And then equal to x. So 1/4 times 4, that's x. And then minus 33. Now at this point, let's take all this and transpose it over to this side. That's 4x squared minus 9x, if we say 8x minus x, and then negative 96 plus 33, that's going to give us 63 equal to 0. Now at this point, you are allowed to use your quadratic formula. If you cannot factorize, or if you can factorize, you can just factorize. Remember, guys, do not just lose marks because you are failing to factorize this. At this point, you already know about the quadratic formula, and then you are allowed to use it. So you can just spare yourself the trouble and then just try to put this into your quadratic equation and find your values. So that's 4x minus 21. If we factorize, then also it gives us x plus 3 and then equal to 0, right? Then this will then give our x values as x is equals to 21/4 or x is equals to -3. But then we cannot take x is equals to -3 because already we can see that that is the x coordinate for the point K, right? And then that lies on the negative x-axis. The point R that we are looking for is on the positive x-axis, right? So that means the correct value here, we have to cancel out this one, and then we only remain with 21/4. So they only said calculate the x-coordinate of R. They're not looking for the y-coordinate, so only the x-coordinate. So we leave it there, right? And then we get our well-deserved 6 marks. So, okay, that's how you could have approached this whole question here for a total of 17 marks. So make sure that you take your time to go through this question here and try to attempt it on your own. Play the video as many times as possible to try and understand the approach that I took into solving this question. So with all that being said, we've came to the end of the lesson. Please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.